All right, guys, hope you're having a good break. I just wanted to take a minute to talk a little bit about the types of questions that you're going to see on the AP exam this year. In particular, on the FRQs, as you know, we're having two FRQs, and one of those FRQs will be a QQT, which I believe they described as a quantitative qualitative transition. And so what I thought I'd do is walk you through a problem that was, I believe this was 2019 question 2. I think I scored this problem. Seems awfully familiar after you reading it 16,000 times. But anyway, I thought I'd walk you through how to keep the two parts separate and to support your answer. And I'll walk you through what I mean by that. So if you look at this question, I apologize, it's a little tough to see. I'll try to zoom in a little bit. It's a circuit diagram. We have two circuits side by side, and they've identified them as circuit 1 and circuit 2. They are identical, simple circuits. I'll read the description and walk you through it. It says the two circuits shown above contain an ideal variable power supply, an ohmic resistor of resistance R, an ammeter A, and 2 voltmeters, VPS and VR. In circuit 1, the ammeter has negligible resistance, and in circuit 2, the ammeter has significant internal ohmic resistance, little r. The potential difference of the power supply is varied, and measurements of the current and potential difference are recorded. So what that means is the following. They have a basic circuit, they have a battery hooked up here, or a power supply. Now this symbol means it's variable. So we use batteries, we could add batteries. They're just saying they have a knob that can turn the voltage from 0 up to some value. So they can constantly change that voltage. It's DC. It's all going the same direction. So they have a power supply, they have an ammeter, they have a resistor, and it comes back, and then they've hooked up 2 voltmeters across the 2 components. So it's super basic circuit. These circuits are identical, except for the fact that the ammeter in circuit 2 has internal resistance. Now, we did a lab this year with internal resistance on a voltmeter. This is just showing the internal resistance on the ammeter. Or sorry, we looked at the internal resistance of the battery. So it's the exact same concept, and we're going to use the exact same analysis to go through the circuit. Now, the key to this is looking at the two parts. They're going to ask some questions. There's going to be a qualitative part, and there's going to be a quantitative part. And then they want you to support these two different ways of a non-mathematical and mathematical have to be linked together. So there's going to be a transition there. So the first part is going to be the qualitative. And the question they asked, and this is the key, it says rely upon concepts, relationships, and definitions of terms to explain. Do not write equations, but you may describe relationships. And you'll see that. We're going to talk about Ohm's law, but we're not going to call it Ohm's law. We're not going to write it as Ohm's law. We'll describe it. In the quantitative, you're going to then use the math. You're going to derive and use equations that represent the concepts related in the previous part that relates to concepts. So you're going to look at this and describe it, and you're going to look at it, and you're going to calculate with it. The question they're asking is, how will the current measured by the ammeter compare in the two circuits as the power supply voltage is increased? Sketch the possible graphs and explain why they have the shape indicated. Now, I had to cheat and write the answer in. I tried this in a row ways using pens, but it was a nightmare. So what they're asking for you to do is to make a graph of the current versus the power supply voltage. So as they turn the voltage up, what happens to the current? And you should realize, of course, that these will be linear relationships. So you're going to draw the circuit and ask you to label them. So I draw a line to represent the relationship between I and the potential difference. And I label that circuit 1, and I draw a similar shape, and I label that circuit 2. And they're asking you to explain why your graphs are the way they are. So how will the current measured by the ammeter compare into sketch possible graphs, I should have said, and label, and explain why they have the shape indicated. So there's several parts in there. So the first thing you have to do is says, I'm going to talk about the shape first. For this circuit, the current is directly proportional to the voltage, and therefore both graphs are linear. Now that's really a statement of Ohm's law. We didn't say Ohm's law, we're just saying these two things have a linear relationship. They're directly proportional. Both include a point to the origin, since with no voltage there would be no current. So we're identifying as proportional, therefore linear, and we're also explaining why it's anchored in this case at the origin. Many graphs are not, but if they are, and if you're going to do that, you should explain why you did that. The key difference, of course, is the slope. So it says the slope, however, is inversely related to the total resistance in the circuit. Since circuit 2 has a greater R total, its slope will be less. So you've given a description about the shape, linear, and why, and you've given a description about why their slopes are different. Now let's look at the math to support this. And in some ways, you might actually think you would do this first and come over and do this, but that's the way they asked the question that particular year. So now they want you to derive equations that will support your answer for the first part. And so we're going to use Kirchhoff's loop equation. It's exactly how we did it when we did our internal resistance lab. And you don't have to know the name of this. You don't have to say Ohm's law, but that's what I did. I said by Kirchhoff's loop equation, the sum of the voltage gains plus the sum of the voltage drops equals 0. That's how a lot of people state it. I prefer to say the sum of the voltage gains equals the sum of the voltage drops around the loop. So I look at the gains equal the drops. And therefore, I've identified in circuit 1, if you look at circuit 1, we're going to have a gain as we go around this loop. We're going to have a gain across the voltmeter, and then we'll have a drop across the resistor. So by Ohm's law, the voltage gain of the power supply equals the drop IR across the resistor, and therefore the current equals the voltage of the power supply divided by R. We're going to do the exact same thing in circuit 2, but of course now we're going to say the voltage gain across the power supply equals I times the internal resistance, little r, plus I times big R, the external circuit when we come back. So we have a similar equation, but now it's adjusted for the fact we have an internal resistance, and therefore I equals V over the sum of the resistors. And then now we're going to support our graph from before. We're going to say since circuit 2, the R total is greater, the I, or the current, is smaller for a given voltage, and therefore the slope of the relationship is less. So for any given voltage value, the value of the I in circuit 2 will be less. So I just want to make the distinction that when you're doing a QQT problem, you want to pay attention. If they're asking you for qualitative information, only give qualitative. Don't use math. You can refer to the math by talking about relationships, but don't use math. When they ask you to do qualitative, when they ask you to calculate something, many times you'll have to derive the equation, or certainly use the equation. I didn't give you numbers here, so you had to derive it. You had to derive the equation out and show relationships, and then relate those relationships back to the graph. So again, I just want to take a minute to talk about this type of problem. The paragraph ones I'm not too worried about. You guys are pretty good about explaining things, but I just want to make sure everybody saw the difference between a qualitative and a quantitative, and to not link the two, not to overlap the two. There's a time later to be able to do the explanation between the two. Okay, we'll talk about this more as we get closer to the exam. But keep this in mind as you're working on the FRQs on the AP classroom. All right, thanks.